So in my last class, we have seen what are the operations we can do in the single linked list, that is the insertion and deletion and traverse. So insertion again we can do in three different operations, that is at insertion of a node at the beginning, insertion of a node at the end, insertion of the node at the middle. And middle means from second position to n minus 1 positions. So I am again debriefing that code. Uh, Let me check this week. Okay. So regarding this insertion at the middle, so what we want to do initially, what we are taking new node of data equal to data and p is star at. So these are two initialization of the new node. So this new node is initialized, that new node of data is equal to whatever the data you are inserting, and p is a pointer which is pointing to the head. Where is the head? So this is head. So here p is here. P is pointer pointing to head, and head is pointing to the first node. So now for the insertion at the middle, what we are checking a condition. So what condition it is? It is saying that if p not equal to null, because p is already pointing to this way. Here I have p is pointing to head and p is not pointing to null. So that means this condition is true, first part. And also k less than position. So what is the value of k here? Suppose k equal to 1, which I have already initialized here, k equal to 1. Okay. And what is the position I want to insert? That position is, suppose I want to insert at the third position. Okay, this is 1, 2, and this is 3. So the position is my 3. At third position, I want to insert this new node, and k is a counter which is initialized at 1. Okay, now what this part is true. This condition is get it true. Now what about this condition, that is k less than position? So k is my 1, position is my 3. So 1 is less than 3. Condition is true. Condition is true. So once condition is getting true, both the conditions, this is logical end, so both the conditions are true. Once both the conditions are true, I am incrementing the k. K is a counter variable, so which is here to initialize. So initially is k equal to 1, and now k becomes 2. So k becomes now less than 2. Now what else I have to do? Q equal to p. So there is a temporary variable also we have to initialize, that is q, which is q is now pointing to my p. Initially p is pointing to head. Now here q is pointing to p. Okay, and p is pointing to p's nest. So p, which is pointing to head, which heads next, p's next means this next. So this next means what? It will become to here. Okay, now so this is a loop. So first condition is true. Now as k value is increased to 2, so I want to insert at the position at 3. So 2 p not equal to null, because p is my here, I have it is not equal to null, so that is condition is getting true again. And k, that is my 2 less than 3, condition true. 2 is less than 3, condition true. So k is incremented, sorry, k is, just a minute, k is my 2 and my position is my 3. So 2 is less than 3, condition is true, this condition is true. Now what I am doing, k is incrementing. So k is increment means k value is getting equal to incremented from 2 to 3. So from here to it has been reached over here. Now what I have to do, q equal to p. So initialize q. What is q? Because where it is p. So what was p? P is already pointed to here. So now this value will be changed to q. So this value will be changed to q, new q. Now what will about the p value? So the p value will be p's next. So what was the p's next? Here P's next is this value. So this is my new P. This will be Q, this will be my new P. So again, this is a loop. So again it will do P not equal to null because P is here, P is not equal to null. Now K is my already 3. So 3 less than 3, here condition get false. Here at this position 3 is not less than 3. So condition gets false. So once condition, this is a logical operation, once the condition get false, so that means the entire condition get false. So it will not go to the loop. Once it will not go to the loop, it will come out of, it will print here, and once it will print here, what it is printing? Q of next equal to new node. So Q of next, that means this part is my new node. Q of next is my new node. And what about P? What about P? New node is of next is my P. So new nodes of next is my P. Q is pointing to new node, and new node of next is which is already P. So that means this connection is established. This connection is, so remember what I have done. I have created two temporary variables, that is P and Q. Initially P is pointing to a head, then Q is pointing to P. Once P is Q is pointing to P, P value has to be changed. What will be P value? P value will be P value's next value. That is the this node, and simultaneously K is to be increased from 1 to 2. Now here, once P is reached over here, here it is checking whether the condition is getting true. No, so then Q will be my new P. What Q will be by the P. So P value will be replaced by Q. P value will be replaced by my Q. Then then what happened? That P will be P next. P is whatever the P, it will be the P next. That means P is pointing to here. Again the new node is there. So what happened? Q of next is equal to new node, and new nodes of next equal to P. So that means this condition is established. So a node is inserted in between. I guess I am clear. I'm clear.
Yes, sir.
Yes, sir.
Vivek Kumar, I'm clear.
Yes, sir.
Okay, thank you. So this is what about we have discussed, like insertion of a node at the beginning, at the end. So this is the beginning insertion, this is the end insertion. Okay, this is the end insertion, and this is the middle insertion. Whatever the position is there, you have to take a two variables. So that's why I mentioned here two next pointers is required, whereas for insertion and insertion at the begin and insertion at the end, only you require only one. Okay. Now coming to the deletion part. So single node deletion, single linked list deletion. Single linked list deletion means deletion again happens at three end, that is the beginning, at the end, at the middle. So what happens? First consider the sequence that is the deletion of a node. Suppose I want to delete the first node. Whatever the first node is there, I want to delete. So what is the first node here? 4, 15, 7, 40. So this is my first node. First node has to be point to the head pointer is pointing to the first node, and the null pointer is pointing to the last node. So first point head pointer is pointing to the this point. So my function is delete node from linked list. So as I have discussed, so I have to require a pointer, that is a head pointer, as well as the position, which position I want to delete it. So the first position I want to be deleted, so that's mean the first position. This position will be 1. So now the variable also required. If I have to counter, okay, so the variable has to be required. If I will require, so I have to from 1 to I have to reach to 2. So that's why k equal to 1. Struct list node, two temporary variables also may have declared, that is P and Q. So what happens if there is no node? First condition, that means if there is a no node in the linked list, how will you delete? Because there is no node. What to delete? That means you have to check the condition first. That what is the condition to check if there is no node in the linked list? The condition is if the head pointer is equal to null. If there is no node, that means there is that if the pointer is there and the pointer should be equal to null, that means there is no value, nothing is there. So that means there is empty checking. So that means there is a no list, that is list is empty. So this is the condition. Please keep remember. So the condition for checking, the empty list is if head pointer equal to null. That means this is the list, there is no element or no node present in the list. Now comes to the second part, that is if the node want to delete, there is a node present, okay, 1 2 3 4, so suppose this is node number 1, node number 2, node number 3, and node number 4, okay, and 4 I have identified as a null, last node, that is because the 4 nodes next is pointing to null, and head is my pointing to node 1, so I want to delete the node 1. So here parameter I pass this int 1 and structure the node, okay, what kind of structure it is. Now p equal to started, so p is a variable I have declared, temporary variable, which is pointing to head, which is pointing to head. So because why head, because I want to delete this head first node variable. So what will be a check, first check whether that node is the first element or not. So what is the condition, the first check the if the position equal to or 1 or not. So if position equal to 1, that means my condition is true. Then what I have to do, then the head pointer which is pointing to the first node, I have to shift the head pointer to the next node. I have to shift the head pointer to the next node. Next node means what? 2. So the head pointer will be shifted to the this heads next. This heads next will be pointing to this. Heads next means this is the node heads next. This head nodes next is this pointer. So this is the next parameter it's checking. So it is going to here. Now as that this link is already broke, so what I have to do, because p was pointing to the head pointer and there is head pointer is already transferred, so p is there is holding to this pointer, because head is pointing to here and p is pointing to head, and I have already taken the head. So what will happen, so p is pointing to indirectly to this node, first node, so I will free this p, I will free this p variable, so that the head pointer is already here. So they see the temporary variable is declared, deleted, and the head pointer is here. So that means there is no issue. So this value is still having the linked list property. Every node is connected and the last node is null and the first element is connected to the head. Am I clear?
Yes, sir.
Yes, sir.
It is understood?
Yes.
Okay. Now coming to the second part, that means deleting the last node of the single linked list. Last node, what is the last node, how to know, as I told you have to traverse all the link nodes in the list, then only you can able to know that whether the element node is the last or not. If the next of the, if the nodes next is not equal to null, then only that node is the last element. So that means I have to traverse the list. So what I am doing here, traverse the list until arriving at the position from which we want to delete. So you have to traverse the entire list to till reach the position which you want to delete. Okay, I want to delete this node 40. So what I have done, if p not equal to null, so p is a variable I have declared, because p is pointing to head. P is pointing to head. So here p is there. P is pointing to head, and head is pointing to the first node. So condition is true, and I want to delete this node position at 1, sorry, position at 1 1 2 3 4. I want to delete the fourth node, which is the last node. So I have to traverse all the fourth node, then only I will reach here and I will delete these things. So what I have to do, k, that is a k is a first variable equal to 1, which is initialized, is less than the fourth position. Yes, true. Then what happened, k will increase to 2 and q will increase to, my p value will be my q value. So this will be my p, this will be my p, q will be my p. Again I have declared q, okay, and this will be my p. And whatever the p, if q has changed, so p will be my new p is next. So what is p is next? So this will be my p, this will be my q, and this will be my p. So this is just swap. Q is pointing to here, and initially p was here, so p will be pointing to p is next. Understood, everyone?
Yes, sir.
Okay, now how long it will go, because now k is 2, I want to delete the fourth node, so k has to be checked again. The condition is to check p not equal to null, because p is present here, it is not null, and also k is greater than less than 4, that is 2 is less than 4. So again k value increase, to what, 3, the k value increase to 3, and this will be my q. So now initially Q was here, now Q will become here, and P will be P's next. The P will be present over here, Q will be present over here. Second node will be my identified as a Q. Q pointer is pointing to the second node, and P pointer will be pointing to the third node. Now again, whatever happen, again that this loop will be run. What happened? P is not equal to null. P is not equal to null, but K is less than position. K is less than this position. So what happens? This will be come out of the loop. So now it will check if P equal to null. P is not equal to null. No. So at the end, print position does not exist. That means if whatever the element you are looking, if it is not exist, then leave it. If then else what happened, because this is not equal to null, else part, what else? It is saying Q of next equal to P of next. So this Q of next equal to P of next. P of next is what? This. Then free that P. This will be my new P, and again Q of next equal to P, and P Q of next equal to P. So again I will delete this free. So again I will explain this again so that there will not be any confusion. Students, please, if you have again any confusion, please ask. Okay, don't remain silent.
Okay, sir.
Let me enhance this a bit so that it will be easy. It will be more possible. Okay. Now what happened? First, I want to delete this position. Okay, that this node, that is the node number 1, 2, 3, 4. So this is my fourth node. I want to delete. Okay, fourth node I want to delete. So what happened? P is a pointer which is pointing to what? Head, and head is pointing to the first node. So what I am checking? P is condition is checking P not equal to null. Very true. K is my 1. So this is the K counter. K equal to 1. Now 1 is less than 4. Condition is true. Once the condition is true, K will be my 2. K is my 2. And Q is my P. Q is my P. So this P will be my Q. That means that first node is my Q, and the what will be P? P will be my P's next. So what is the P's next? This is the second node. So Q will be my first node, and P will be my second node. Okay, now what happened? Now what happened? Now what happened? P is not equal to null, and as well as that P value, that is K value, that is 2, which is less than 4. Condition is getting true. So K value is increased. Now K value getting to increase to 3. Then what? Q will be my new P. So this P will be replaced to converted to Q. Okay. Now what will be P? P will be my P of next. So this is P of next. So this P will be my P of next. So here what happened? Q will be my second node. P will be my third node. I want to delete the fourth node. Now again loop will start. P of not equal to null. Obviously P is not equal to null, as well as the K. K that is 3. K is my 3, which is less than 4. Condition is true. So K plus plus it will happen. So K will be my 4. K is reaching to fourth position, which is I am going to delete. And Q will be my P. So Q, this P will be replaced as Q. And what will be P then? P will be P's next. So this will be my new P. This will be my new P. So I have reached at the position which I am going to delete. Now again what happens? The loop will be condition check one more time. That is P is I pointed to null. That is means true. P is equal to null. P is equal to null. But here what I am checking? P not equal to null. Is P not equal to null? No. Then this condition will not getting executed. So what it will do? It will come out of the loop. Then what it is checking? If P equal to null, that means if P equal to null, what will you do? Position does not exist. Once this value you have reached at position. Now what else part is saying? q equal to next, p equal to p is next. So this value q equal to q is next, because this value p is next is pointing to null. P is next pointing to null. So q's next point has to be pointing to null. Then only you can delete. So q's next point will be p's next, because p's next is pointing to null, and you remove this p. The old p is getting removed. The old p is getting removed. So previous node to tail. Now, as I am saying, so q's next to be null, and this tail is getting to be removed over here. So because it is already, it has to be nailed, and this linked list property is maintained over here. So now it is easy to remove. Tail is nothing but the spree. So I have removed this p. Now what I am saying, deleting an intermediate node in single linked list, similar to the previous case, maintain the previous node. Like suppose I want to delete the middle node. So this work will be checked whether with this middle also not. So what happens is q of next, actually in this slide there is a something wrong. So here you have to remove this free p equal to free p. Okay, so this part will only execute if it is a middle node. This else part will only execute if you are trying for middle node, and this part is only at the end node. So this print is, I mean, this you have to remove this thing, and actually I wrongly written over here, forgive me. So this has to be free p actually. Okay, so now this q's of next equal to p's of next, because q of next equal to p, this is p, this is q. As we are traveling from here to here, initially p is pointing here and p is pointing to there, then q is pointing to p and p will be next p. So p of next is q. Now q is next, p equal to p of next. So qp, like in this way, it is travel like this way. Now I want to delete this p. So what I am doing, q of next equal to p of next. What is p of next? This is pointing to the node 4. What is q of next? This is pointing to the, q is pointing to the 2. So q of next equal to p of next and free p. First you have to establish the link, then you delete that node. Am I clear?
Yes, sir.
Yes, sir.
Am I clear, student?
Yes, sir.
Sir.
Okay. So these are the things for this today's class, and for right now I will ask you few things to do. Okay, like I can ask you, like you go to your things and try this code, because today you have class, you have, this is 3 up to 3:30. Okay, so you try that particular code which you have not done, because I have taught to the linked list part. So you go to the hacker rank which you have not done in last class, you try that thing and submit to me. You have 30 minutes time, go through this and try these things. Okay,
Up to, sir,